Hey guys, so today I'm going to show you how I made this rounded embossing. It's quite tricky to do with a displacement map made in Photoshop, which is why I ended up using Houdini for it. So just for this tutorial, I started by making a bottle in Blender real quick. And then I made a black and white map in Illustrator, just drawing a bunch of pebbles and making sure they're nice and smooth. So I started by bringing in my image here, which is massive. So I scaled it down using a match size to 10 by 10 by 10. Then using a trace, it turns it into polygons. Then we get rid of the one in the background. Turn that into a polypath and resample it to control how many points we want on it. Next we fill it back again and remesh it. There we go, nice and dense. I made sure to up the smoothing a bunch to make sure the triangles are nicely distributed. Then we use a fuse to clean it up a bit and group the unshared edges. We're going to use that group in a pin constraint. Pin to target, permanent, so they're locked in place, and when we run a vellum sim on it with default settings, we get this. That's how we get our nice and rounded shape. So next we do a bit of a point deform. I remeshed this to a quad topology using quad remesher. And with a point deform, we can make it take the correct shape. So the rest point lattice is going to be our sim on frame 1, so it's flat. And then the deform point lattice is going to be our sim with the desired shape. Cool. The problem here is that the smaller the island, the smaller the depth of it is. So to make sure they're all on the same depth, we run a for each connected piece with a couple of match sizes. The first one is going to be controlling our depth. So it's just set to scale on the y-axis. And the second one is set to justify a max on the y-axis again, so that they don't end up moving. If we don't have it on, you can see they move around. And now they get scaled from the top. Cool. Also, I forgot to mention, in the point deform, you want to make sure you're at 0.01 on the radius. Otherwise, what it does is the edges aren't quite where they should be, as you can see. Cool. So next up, we transform it, so rotate it, scale it down a bunch, and move it up on the y-axis. So if I template my bottle here, you can see we're more or less aligned with how we want it to be. So next up, we want to create a single plane out of this and wrap it around the bottle, and then use that plane to point deform our little rocks here, or clams, I don't know what you want to call them. So we start with a bound, and then group these points here facing the front and delete everything else. Then I used a detail wrangle, but you can do this with a measure swap. I'm just creating a vector that returns the size of our bounding box of the object, and then creating a float attribute called size, which gives us the size on the x-axis. And I can use this in the bend here on the capture length. So make sure it deforms in both directions, and then play with the axes here and capture direction until you get what you want. And boom, now we have a perfect circle. The advantage of using the capture length here is that even if I transform it, like scale it up here, it's still going to stay a perfect circle. Alright, cool. Now we need to align it with our bottle, which I do with a transform here, and array it to the bottle to make sure it takes on the shape perfectly. And now we can use the point deform. Again, 0.01 for the radius. So as you can see, our mesh to deform is this right here. Then we've got the flat version of our grid for the rest point lattice, and then the projected version for our deform point lattice. And cool, that's how it's done. Next up, just use a boolean to cut into our bottle, and a polyfill to fill the top here. So we can turn it into a VDB, do a little bit of smoothing, and turn it back into a mesh. And that's how I did it. Thanks for watching, hope you learned something, see you next time.